So in this video, we're going to look at a series of special types of sequences. Our first sequence is the finite sequence. If it is finite, it just means that there is a fixed number of terms. So for example, 1, 3, 5, 7, 9, if we stop there, we've got a sequence. It's going up in twos each time, but there are 5 terms to that sequence, so it is a finite sequence. Then we have the infinite sequences. That means that there is no fixed number of terms. So we're not going up to 5 terms or 100 terms. There is an infinite number of terms. And an example of this would be looking at all even numbers. So 2, 4, 6, 8, 10 and so on. If you carry that on, there's an infinite number of even numbers. So that would be an infinite sequence. Then we've got the concept of an increasing sequence. If it's increasing, it just means that the subsequent term is bigger than the previous term, or mathematically, u of n plus 1 is greater than u of n. Now this is true for all natural numbers for n, because n represents the number of terms, so it is a natural number, such as an example, 2, 4, 8, 16, 32, it keeps going up each time by a multiplier of 2. A decreasing sequence is the opposite. Each subsequent term is less than the previous term, such that u of n plus 1 is less than u of n for all n, where n is an element of the set of natural numbers. An example, 10, 8, 6, 4, 2, and keep going. You're going down by 2 each time, so it's a decreasing sequence. Our final type of special sequence is the periodic sequence. This means that the values repeat indefinitely. So for example, if we have 2, 4, 6, 2, 4, 6, 2, 4, 6 and so on, it's going to keep repeating, so it's periodic. And for this particular sequence, because it repeats every 3 terms, 2, 4, 6, then 2, 4, 6, it means that it's got a period or an order of 3. So let's use the concept of the last 3 and let's use that with a few problems. So we're given for each of the following sequences, we want to state whether the sequence is increasing, decreasing or periodic. And if the sequence is periodic, we want to write down its order. So if we look at the first sequence, we're given u of n plus 1 is equal to un plus 3, where u1 is equal to 7. So let's just start to list the terms then. So we've got 7 is our first term. The next term, if we put 7 in, 7 plus 3 is 10. 10 plus 3, 13. 13 plus 3, 16. 16 plus 3, 19, and so on. Well, what's happening each time? Well, the subsequent term is bigger than the last term. So as u of n plus 1 is greater than un, this implies the sequence is increasing. So the first one, we've got an increasing sequence. The thing that really gives this away is that we're adding 3 each time, so it must be increasing. If we then move to the second sequence, we're given u of n plus 1 is equal to un squared, where u1 is equal to a half. So let's do the same again. Let's start to list terms. So our first term given is a half. If we substitute a half in, a half squared is a quarter squared is 1 over 16, and so on. So this time, each of our subsequent terms is less than the previous term. And if it's less than the previous term, that must mean that we have a decreasing sequence. So as u of n plus 1 is less than u of n, that implies the sequence is decreasing. Let's then look at our final sequence. We're given un equals sine of 90 n degrees. So we're looking at degrees for this, so just be careful if you're substituting in. Now again, our n is a natural number, so 1, 2, 3, 4, and so on. So when we have n equals 1, we've got sine 90, which is equal to 1. When n equals 2, we have sine of 180, which is equal to 0. When n equals 3, we have sine of 270, which is equal to minus 1. When n equals 4, we have sine of 360, which is equal to 0. When n equals 5, we have sine of 450, which gets us 1. And what you will start to see is that we end up with a pattern 1, 0, minus 1, 0, 1, 0, minus 1, 0, and so on. And because it's a sinusoidal function, it's a sine function, this will carry on indefinitely. So it's an infinite sequence, really. But actually, we can see a pattern. We've got 1, 0, minus 1, 0, 1, 0, minus 1, 0. So we can say that the sequence is periodic because it's repeating. But we can also give an order for this. That's what part B says. So we can say with an order of, and then we just need to count the terms. We've got 1, 0, minus 1, 0. Then we repeat 1, 0, minus 1, 0. So for each bracket in between the repeats, we have 4 terms. So it's an order of 4 as the sequence repeats every 4 terms. And that seems a sensible way to clarify that at the end. So you've got 4 terms, then a repeat, 4 terms, a repeat, and so on. And that is a video looking at a series of special sequences and then using some of those to define a few given sequences.